Okay, so you should be able to download these. Uh, Let me see if you have these handouts or not. So since we are, getting started with some demos, so I'm going to get started, with this PDF that is available to us. I'm sharing my screen, okay, and I'll be going according to this very, PDF, which is this 13 pages PDF. And as in when we move through this PDF, okay, we'll get to see the operations in Hive, right? And as and when the operations come, so I will explain you how we are executing the queries and join operations and things like that. Okay. Further on, I'm also making a note in my notepad as to uh, uh, the book that you can refer. I'll mention one book, which you can always refer to learn Hive further. Okay, and that is a fantastic book in order to almost master, Hive operations. So the learning curve for Hive is dependent, on how quickly you happen to learn its operations. So it's a data warehouse application. So the architecture-wise, it is pretty straightforward. Whereas when we get to the intricacies, okay, the nitty-gritties of this Hive application, then it can be a very powerful tool. Okay, so I'm going further into the next slides. And the next slide tells us introduction to Hive and its architecture. So it says that Hive is a data warehouse infrastructure tool. We know about this, and it sits on top of Hadoop, okay, to summarize big data and making queries and analyzing easy. And this is a brief tutorial. So this is a tutorial PDF, and we'll be using Hive HQL. So Hive brings along with it the Hive query language, okay, which can be run, and then you get the results from it. And it's tightly integrated the Hdfs. We know about it. So features, these are the features we had discussed a little earlier. This is another image. Okay, so Hdfs at the base. We have the metastore over here. This is the metastore. Then we have the processing engine. Okay, and we get the tools like web UI and command line so that we run the queries. So you can go through these, okay, few pages, and I'm going to go to, let's say, a create table statement. Okay, so this is a create table statement, which is very straightforward. We just need to give create and then a table and then a table name along with the syntax as we give in the what do you call MySQL. Okay. So to get started, this is the screen which I also showed you earlier, and we'll move to the next. So this is the web browser screen. We can use both web browser as well as command line. It's the same thing. Okay, and this is the select star from. So I'll just show you how we do this. As soon as I do something like select, see, it's straight away bringing up. So you just need to hit the word, select, let's say star, then from. So see, it pops up the tables automatically, right? So if I say something like say customers, and I'll also say limit to 100, and that's it. So this query can be run in the GUI. I'll just broaden it up, and see there we have the answer from this table. So we have these 100 results from the customer table. So that's a very basic query. We'll move into some advanced operations from here. This is a basic query, select star from sales, and that's the text user interface given. So I can give this very same statement over here also in the Hive prompt available to us. So I'll have to go to the Hive prompt first and then run the statement. So more or less it's going to be the same. and that's given on the that is the text user interface, and we use select star. Okay, so we used from customers. So I'll go back to this and I'll say select star from and limit to 100. So I think I should have answered your query over here. See, this output is neither on the Hdfs, okay? It's only there on your console, right? So when the output is on console, you need to use the RESTful API, right? We have to use an application which integrates with Hive and runs such a query. Okay? This output is not really going in Hdfs. So if I had done further, select star from customer, and if this was integrated with another query to input this result into another table, yes, that was possible. And that would have gone into Hdfs. Yeah. So hope any questions? Any questions up till now? Okay. Now, using Hive to map an external table over weblog data in Hdfs. So let us see the prerequisites for running this. You will often want to create tables over existing data, right? That does not live within the managed Hive warehouse in Hdfs. Now, one of the best examples I'll provide for this is our very file. I'll show that file. It's on the desktop. And if you recall from yesterday, see, this is the company's master data file. So if I do something like more and this file, see, this is the 430, 450 megabyte file with about 13 columns. Now I could possibly, do something like Hadoop, then, fs hyphen put this same file. Where do I want to put? So let's say I create a directory in Hdfs. So let's create Hadoop fs mkdir companies. Yeah. So if you want to further see that this directory has been created, so let's see from ls. Okay, when I do just ls, so we have these different, and if I do ls, then further companies that I just created, so which is an empty directory. And now we go with Hadoop fs put, which is the company's file, into the company's directory. So this I intend to write in the Hdfs. And if you want to see this interactively, go into Hdfs, okay, and go into the Cloudera directory, and so see, there we have this company's directory, and this particular file is being copied because it's for 30 megabytes, so it's taking some time to copy there. And now that we know that this file is a CSV file, right, we can use Hive to schematize this, right? So I'll be doing that later. However, we'll come back to our, lab 2, wherein this is the line because of which I created the new CSV file in Hdfs. Okay, this is the scenario that when you have new data in Hdfs and you have not schematized it, you have to first schematize it. Creating a Hive external table is one of the easiest way to handle this scenario. So we are basically going to create a external table from a file. Okay, queries from Hive client will execute as they normally do over internally managed tables. So make sure you have access to the Hadoop cluster with Hive installed, which we do have. Okay, this recipe depends on having the web logs entry dataset loaded into Hdfs directly. So let me show you where this resides. Okay, I'll go into day 4, and these are the two tables, okay, that it is referring to: weblog entries, okay, and the IP to country. These are the two that I'm going to copy, okay, and then put them into the system desktop. I'll place them over here. Okay, so these are the two new data sets. And if you want to see what the data sets look like, so it's still taking some time. Okay, that's complete. So we have some new data, and I'll show you what the new data looks like. So the new data has weblog entries. Okay. So the weblog entries data set is nothing but a log file, okay, of a web server, which includes I think this is the checksum, this is the file, that was accessed, the timestamp and date and timestamp, and from an IP address, right? So this is a regular thing, and I'll upload this very file, okay, in Hdfs just the way I have put that. Let's first see what are steps defined. So it says add a create table syntax as follows. Okay, so MD5 is string URL, okay, and request date, request time, and IP address. So this is typically the same, uh, structure as we see over here. So we have this MD5. MD5 actually stands for Message Digest 5. It's an algorithm for encryption. And then we have the URL, and then the remaining. So now see, this is the directory where it is being put, right? So before doing this, I'll create a directory in Hdfs, and you can also do -p, just the way we do in Linux, as /weblog, right? I'm going to create this directory. And then we put the weblog entries, in this file and this directory. So that's where we place the particular data set. And then it says to open the VI editor, okay, and put this particular syntax out there. I was telling you earlier that Hive can be run with a -f option, right? So it says that you just open through VI editor and save this as any, weblog external or any file out there with an HQL extension. Extension could be again any. We don't have to make it as HQL only. So it says drop table if exists. Okay, weblog entries, create external table, and then this is the structure being defined with the row format delimited fields by tab. Okay, it is tab separated file terminated by n. /n is a end of line terminator. And the location we have given is /input and weblog. So I'll save and quit, and then we are going to run this. So we have already created this, okay, and we have already put this file out there, and all we need to do is run this Hive statement. So the Hive statement basically, this PDF has been shared, so check if you could check with Bilal. This has been shared already. So we have Hive-F is the file which I just created, which is the weblog.html. So before running this, let me show you what is the content of the file. So cat, and see, that is what the file is, and we are going to run the Hive command now. So as soon as we run Hive, it reads the content of this file. So -f is the parameter to read your HTML file. So now you may be wondering why we are giving a -f. Why? Because if you are familiar with Linux cron jobs, okay, or Unix cron jobs, or scheduling in Windows, okay, scheduling can be done in advance. Let's say I want the home directory to be backed up at 12 o'clock midnight. Okay, that is one of the cron jobs. So for Hive also we can make use of Oozie. Okay, so Oozie is it's a Hadoop ecosystem component. Okay, it's a very complex tool rather, but simple to understand. When it comes to deployment, it is more or less quite complex. But it's the cron system of Unix and Linux systems. Okay, so Oozie is the cron, or Oozie, what Oozie is to Hadoop, cron is to Linux and Unix systems. So we can basically schedule the workflows. Okay, and in the workflows you can put Hive, big scripts, and a couple of others supported in Oozie. Okay, so I'm now going to run this Hive-F weblog. So let's see that it creates an external table. This way we have the table created. Okay, have you followed it? Any questions up till now? Let me know on chat. So it is just created in about so many seconds. Okay, and now absolutely I can run something like, I think it's Hive-E, and then we see show tables. Okay, I didn't give the semicolon. Even now it's not. Let me just go back to Hive prompt and do a show tables. So see there we have the weblog entries. Let me just show the same weblog. See, it's create external tables, weblog entries. So this is what it has created just now. Yeah, and so if we show describe weblog entries. Now, can you tell me where this comes from? I'm going to ask you two questions. Where is this output on your screen coming from? Okay, That's the first question. And then I'm going to do a select star from weblog entries. So anyone who would like to answer this? Anyone who would like to answer where this output is coming from? So it's coming from the metastore, right? No, it's coming from the metastore. This output, when we say describe weblog entries, it's in metastore. Whereas when I give select star from weblog entries, this is what is actually in the Hdfs. Okay, so when as soon as I give select star, so now it's interfacing the the Hdfs, and we are getting the output from Hdfs. So if we again look at it from a sequence, first we had a CSV file or a TSV, tab separated file. We put it into Hdfs. We schematized it using this HQL. You schematized it, right? We made a schema in the metastore. Now after having created this schema, then the schema was created in metastore. We now fetch the results by sending a request to the metastore, thereby getting the results from Hdfs. So these results is the star. So when I say select star, it shows all the results that are available in weblog entries. So we have the entire table in weblog entry. And the same way that we have done this, okay, you can also do the all companies data set, okay, which is an even bigger data set, right? Which I can do. So all we'll need is the the complete the database sequence, and I do have it. I do have that database structure somewhere, so which I'll be doing shortly. So let's move on. After creating our table, right, external table, we see that the table has now been created in Hive, and now we shall move into the next, which is using Hive to dynamically create tables from the results of a weblog query. So I'll read out the text. This lab will outline a shorthand technique for inline table creation when the query is executed. Having to create every table definition upfront is impractical and does not scale to large ETL. Okay, so I believe you would be aware of ETL, extract, transform, load processes that I had mentioned earlier. So being able to dynamically define the intermediate table is tremendously useful. Okay, so these statements. In this lab, we can create a new table, okay, that contains 3 fields. Now we are kind of doing an ETL. Okay, we are extracting some statements or some rows from the table that we have, okay, and then record that into a new table. So we have also done the describe weblog entries, okay, and then it says that carry out the following procedure, okay, to create an inline table. So what we are doing is create table weblog entries with URL length as select. So I want to record the URL length in one table. As select URL and these 4 things from weblog entries, and we'll record them into our table. So I'll put that into one of the other so we'll name it as weblog with URL, and let's open this and put the required text, which is create table. We select 1, 2, 3, 4 columns from there, and let's see. So we save and quit this, and then run this one. So we'll say Hive -f and this particular SQL. So I mentioned earlier, when Hive is performing larger queries, okay, so it turns them into a MapReduce task. Okay. So once again, create table, because we are creating a new table from existing, HDFS data. So it has created a job, all right, and we can actually go into our cluster and see there in the applications screen. So let's turn to the full view, and we'll go to all applications and see which is the running one. So system is actually too busy, it doesn't even allows us to click. So this is the one, I think, yeah, this is the one. It is in the running stage. Right. So you can view further some more parameters. So when a job is running, it shows in the scheduler as to how much resources have been provided to each of your nodes. So this is the node, okay, and it's telling us these are the resources that were provided. So I guess the job has finished now. Okay, yeah, the job is finished, and we should be able to see the new table created. So let us see what it has done. This is where it started, and it's logging, and it says 3 jobs were there. Okay, and also, so this is the map and reduce. Okay, that we had seen earlier, and then it says moving data to HDFS into warehouse, and finally it says that it has created this particular directory in this URL. So at this point we can run a command, let's say Hadoop fs -ls, and then we give the full path, so that we will be able to see the output of this result, right? That is the resulting file that has come. So either you can do a cat over here, right? If I do a cat, it's going to show the entire thing over here itself. Okay, so it's a directory, it says. So we should do a length and then these zeros. So it means, see, Cloud Hive will always write data and it will consider one directory as a complete table. Okay, so I'm just going down to the user Hive and warehouse and this one and there. So yeah, this itself is a file, isn't it? That itself is a file. It is so big, 118 kilobytes. So that itself is a file, and I told it to cat earlier. Yeah, so this is what we can cat. So as I said, you can either display, the content of this file, or we can also see the content comes like this. It's quite difficult to understand. So we are not really supposed to see the content through cat. We are supposed to see this through Hive command, right? So at this point, I can again do show tables, and we know that it has created this table, right? I hope you have gone through the table creation text. So here you can do a, what do you call it, describe first if you would like to describe, isn't it? Why I am describing is because we created the table with dynamic, dynamic entries. So we did create table, this one as select URL and so on and so forth. So URL, request date, time, and this. Yeah. So we requested, we said to select only these four, okay, from the weblog entries and record it into this table, right? Whereas if we go for describe weblog entries, it's a larger table. Okay, so it's a bit of larger table. We had MD5 also there, okay, and IP also. So we have taken off these things, and we also calculated the URL length as the function, okay, length of the URL, and stored it as URL length. So the output goes there, and then we can move on. Any questions up till now, guys? Okay. So the next one is, it says Hive does not directly support foreign keys, okay, which is quite a lot like MySQL also. Nevertheless, it is still very common to join records on identifying matching keys. So joining table, broadly we are going to do a join. So it's further says this recipe will show a very simple inner join over weblog data that links each request record in the weblog entries table to a country. Now the point is straight. We have a weblog which is apparent from the output that we see over here, right? This is the weblog as it appears, and all we have is the URL the person is accessing and the IP from where it is being accessed. We don't know anything more than this. The URL being accessed from our server and the IP, whoever is accessing from elsewhere. It could be a web bot also. So whenever it is a web bot, we have specific entries in this. So the entries are normally blank. Okay. So you can ask me otherwise if you want to do the web analytics. So those entries go blank. We don't get to see the geolocation, and we don't get to see few specifics when it is a web bot. So like Google web bot and Yahoo web bot. So with this output, we don't really get to know which country is it coming from, right? So for that reason, we have another file called as country to IP database, and that is also available on your desktop. If you see this particular text file, so I'm going to display that. See, it contains two columns. One is the IP address, and the second is the country. So I could do a WC-L to show you how many such, we have 3,000 IPs, a record of 3,000 IPs. So there are some realistic IPs also available, okay, which are sometimes commercial. You do get data sets wherein you get a uh, mapping of IP to country, mainly to map as to which country your visitors are coming from. Um, so I have this realistic example also on one of my domains. I can show it to you. See, this is that record, okay, and the way it is being handled at on this end, the way I am handling it. So this is the IP on the column A, and then we get the no host name. I mean, no host name means it is a crawler, okay, or sometimes due to some reason the host name is not provided. So see, this is a Google bot, for example, okay, coming from California, and so these are the coordinates. So this is a separate table, created to record these values, and then we have, let's say, even the timestamp. So I've made timestamp as another field so that it records that specific timestamp, and we don't have to add an entry in the MySQL table, for adding a timestamp. So this was it. And coming back to our example, we'll first, look at the country to IP database or data set. So then these are the same lines, and we need to have the weblog entries, which we do have, isn't it? And then it says that you need to have the IP to country data set. Copy this to Hdfs into the same directory. So what we'll do is we'll just put, just as we had put the weblogs, same way we'll put the IP to country also. And the place it is saying is in input directory. So, is it in the input directory? IP to country. So this is what the directory should be. Within input, it's saying you should first create an. So I'll just add this entry in my notepad, and we'll first create a directory, that is mkdir, and which is going to be IP to country. So after this is done, then we go ahead with the next command, that is Hadoop put IP to country.txt in this particular directory. So that should go there, okay, and then we would create another SQL with VI editor, okay, IP to country dot HSQL, and we are going to add these lines. So drop table if exists, IP to country, right, and create an external table with IP string and a country string, and location is from input IP to country. So there we do, and again we run with Hive -f this particular HSQL. So that should be done pretty soon, okay. That should be done. And now it has been created. So we'll go to our Hive prompt, okay, and find out whether this has been created or not. So we do our show tables and see there IP to country has been created. So we describe this, and we know that it's very straight, and we can run something like, select count star from IP to country. So as I showed you, there were 3000 lines. So even for this small task, it has started off with a MapReduce job, and that could be one of the reasons that Hive is not preferred to be the tool of choice. So there we get 3000 rows, and now coming to the inner join. I hope you guys are following this. Let me hear from you in the chat. Any questions up till now? Okay, thank you, Ashwin. So you'll have this handout, okay? Let me check with Bilal if you have got this handout, and you will be able to do the same lab exercise. So I'm now going to perform this inner join, okay? I believe you would be aware of an inner join, okay? Now, see, for those who are new to the databases, see, a join is when we have multiple tables, okay? And I had mentioned earlier, when you want to extract similar, fields from those tables, or you want to reference those via those fields, and then create separate tables, based on your query. So this is what we are going to create here. That we know there are 3000 IPs known, okay, and then we know that there is a complete web logs entry table, but we don't know which user is coming from which country, okay. So that is required, and for that reason we are going to run this, that is select wale.star comma itc.country from weblog entries, right? So which means this is coming from weblog entries, and join IP to country on wle.ip, right, equals to itc.ip. So this we are going to save in another SQL file, or you can also run this straight over here in the Hive prompt. I will create a new uh, let's say file called as hivejoin.hsql, or sometimes it is also referred to as HQL, right? And I'll save it, okay, and then it says you can absolutely run the same thing with -f. So I'll once again show you. This is the statement we are going to have, and this time, see, we'll run it with Hive, but I'll also append it with time, okay. I told you earlier that you can append anything, any of the Linux command with the command time itself, which will tell you the exact time which it has taken, okay. So although Hive does tell us, but time command will tell us the system time. So now I'm going to run this. So see, it has started off with one MapReduce process. Okay, now when we see the real system time, okay, this is the system time displaying, and so Hive also tells us the similar, because that's post going into the Hive prompt and all that, right? So that's the time taken, and as you now can see, that if I just broaden the window, okay, so window is broad enough. What we see is that for each of the URLs accessed by a user at IP, we also have a location like Colombia and United States and so forth. So this further can be put into another table like we have done previously. You can do this into a table also, right? And I believe this was interesting example to note. Okay, so let me know if you have any questions, and then we'll just look at some other uh, concepts of Hive, and we'll turn back to our Cloudera CDH. Any questions? Okay, so guys, you would be having these handouts, okay, pretty soon, which is working with Hive. Then today's today's presentation, and so if you would like to continue some work on Hive, you can do so. So we can take a break of about 5 minutes and then move on from here. So handouts are being provided. Just wait for about a few minutes. Your handouts will be available in the handouts section. Now, let me hear from you. How was the demonstration on Hive? Okay, and if you have any questions, feel free to ask. Okay, related to Hive also, and if we do have time. Okay, so I think let me see if we can cover one other topic in Hadoop and big data. So I'll be able to show you one or other interesting topics. Okay, we have a question on object inspector functionality. So see, Hive is made in Java itself, and the the functionality of object inspector is to analyze the internal structure, okay, of the row object and also the structure of the individual columns. So when Hive has to read the tables, okay, we provide them, we provide Hive uh, the way it should be, reading it. So I'm going to present a few slides again, and see from there. I'll be explaining that. Uh, Share it. So see, I'm going to share the HQL. See, we have been going through this screen, right? So although I told you about I hope everyone can listen to me. Yeah, you can hear me, right? Uh, I would be happy to see your replies in the uh, question screen. Okay, Chandan says yes. How about the rest? All can hear me, yeah? Madhuri? Okay. So, see, on your screen, you should be able to see uh, the slide on why another data warehousing system, right? See, this got started in Facebook long time back. Okay, so it was developed by Facebook, and many people today ask the question, as to Facebook has started, and why should we be adopting it? Hold on, just to give me a minute.
Hello, Manish.
Yeah, Bilal, give me a minute. Just give me a minute.
Yeah, Manish, the contents are being shared in handouts, huh?
Okay, okay. Thank you.
Yeah.
Hi guys, sorry for this interruption and small delay. So Bilal has just announced that he has, he has provided you with the handouts, right? So go ahead and uh, explore the handouts, right? And we can just look at the slide which we have in front, okay? So why another data warehousing system, which came from his Facebook, right? And we have the problem states that data and more data and several terabytes of data every day, right? So the Hadoop experiment was through Hdfs, and then Facebook went on to have Hive. So the problem lacked expressiveness, MapReduce hard to program. So that is how Hive was given birth, right? Hive was started. So what is Hive? A system for managing and querying unstructured data as it were structured. Uses MapReduce for execution, Hdfs for storage, right? So uh, we have seen MapReduce happening, okay, and Hive uses MapReduce on the backend, right? To put it simply, Hive makes Java classes, okay, and it executes those classes as MapReduce programs, okay. So key building principles, it's SQL as familiar as data warehousing tool, extensibility is there, okay, interoperability. So you do have interoperability among other systems, okay, and performance wise also. So yeah, broadly looking at it, if you get to work on Hive, okay, then you should be also be able to work on what you call you would be able to work on Impala also, and other data warehousing system that are available on Hadoop. Okay, so we do have NoSQL systems. So besides Hive, you should definitely go in for NoSQL systems. The overview part, which I will definitely will be telling you today. Now, we have seen creation of tables, okay, and creation of uh, what you call joins, right? And you would have noted that we use in these are the primitive types, okay, including integers, small int, big int, okay, Boolean type, float, double, string, okay, and in complex types we have structures, maps, and arrays, okay, which are being used in Hive data warehouse. Okay, so tables are analogous to relational databases as we have seen, and each table has a corresponding directory in Hdfs. This is the point to note that when we create a table, okay, either dynamically or we create it statically in the beginning. So I'm going to share my screen and show you by going in the Cloudera, and we'll go into one or the other tables, okay, in Hive, and over here you can see the Hive warehouse directory within which all these tables are existing. So if I look at sample 7, okay, which is a sample data, right? So this is one file over there. So each directory, okay, in Hdfs uh, represents one Hdfs table, okay, and we have to create the structure and metadata. So I can show you similar directories. Okay, we'll go to the user Cloudera or somewhere else. Let's say we'll go to user/Cloudera, and if I take you to companies, so this cannot be called as a complete uh, Hive table, okay, as long as this is not schematized. So I'll have to make a schema of this, okay, and only then we can refer to it with select statements, right? So further, we have these create table commands, okay, create table, and within this we give the primitive types, okay. So primitive types, as you have seen here, a string. So DS has string, float, okay, list, and we are also giving map and structure type of uh, uh, data structures. So the data models, okay, which includes the partitioning. Okay, so yesterday one of you were asking about the buckets. So we do have partitions and buckets in Hive also. Okay, so analogous to dense indexes on partition columns, nested subdirectories in Hdfs for each combination of partition column values and allows users to efficiently retrieve rows. So as you can see over here, right, that HDFS for DS equals to, let's say 2012, okay, this is one date, and April 10th, so 10th April 2012, then country is US. So this is only for this one particular directory. As you can see, this is the directory that will be accessed. And when we say country is India, then within the same date, okay, the country India will be accessed. So that kind of partitioning can be done in Hive query in Hive itself. Okay, so we have seen Hive query language earlier. Okay, that is by the way of partitioning. Okay, and creating tables, creating partitions, right? And so we can go ahead and say create table partitioned by a specific, ID over there. Insert, override, then table test part. So we can absolutely go ahead into partitioning, and this is continued. So select start from test part where ds equals to this. So this, as I said earlier, will only fetch the results from this directory. Whereas when we give the next statement where ds equals to this 2009-0202, okay, and hr equals to 11, then it will only be bringing this result, right? Clear with this? So see, buckets, as I was telling you, splits data based on the hash of column. So you can actually, based on a hash, you can subdivide your data. Data in each partition may be turned into, divided into buckets based on the value of hash function of some column of a table. So some of the columns, can be isolated and put into buckets. So bucket column user into 32 buckets, right? And so this way, yes, we can absolutely partition it. So that is the modeling, right? We also have serialization and deserialization. So see, in the Hive engine, we always tell Hive to read the data. So what it does is it has got a class called as Surday. Okay, Surday is the small or short for serialization, deserialization. Okay, and it uses the lazy Surday, okay, flexible interface to translate unstructured data into structured data. So basically, this is a driver interface through which it is, communicating the data. So just like you have XML interchange format, and this is the jar file. Okay, so if you are further interested, you can see the jar file. Okay, and within which the Surday drivers are located. Okay, then we have the file formats. So just according to the Surday, we have these file formats. Hive lets users store different file formats. So as you see that there is integer value, string value, that is the way you can also have different file formats. So file formats is altogether a different topic in Hadoop, okay, and it is mainly related to the Hadoop developers, okay. So let's say when we do create table, destination or dest1 key is integer and the value is string stored as input format, and so there we are providing it as a sequence file input format. So sequence file is one of the Hadoop file formats. So for further reading, I would suggest the definitive guide. That is the best even if you are going for Hadoop development. So sequence file format is both put for input as well as output file format. So these are the few slides that we had initially gone through, and then we start off with the Hive query language. So besides SQL, you also have the DDL. Okay, so in DDL we started with data definition language, wherein you create, select, create table, okay, and use table, create database. Those kind of things come, and then you have this HQL. So very similar, Hive definition language and Hive query language, and so we have these Hive query language join. I did one join, right? So from two tables you join and provide one output. So that is the insertion. If in case you want to insert into any table, insert override table sample one, and this is local system data, and then we are saying select star from sample where ds equals to this. So this is not actually local. It is always Hive is always interfacing with the Hdfs, right? So there it is Hdfs output. And so these are some other examples wherein we have override table, override directory, and override local directory. So that way, yes, you can have Hive QL. Any doubts up till now? So I have from Chandan Singh saying, in case of embedded Hive, can the same metastore be used by multiple users? So what do you mean by embedded Hive? See, Hive has come in mainly two versions. There is Hive 1 and Hive 2. Okay, and so there is embedded Hive is basically, I mean, you have to elaborate on the Hive, deployment. There is a specific way in which Hive is getting deployed. I can show one slide to you as to how Hive is getting deployed. Hold on, give me a moment. I'll just open that up. Okay, I have got some slides from one of the Cloudera, exercises. So I wouldn't mind, explaining some topics from here. See, Hive, okay, is an open source Apache project. So I'm just opening this slide to tell you the architecture, how Hive is implemented. Okay, so motivation. Many data analysts are very familiar with uh, the SQL query language. Okay, so the RDBMS. So Hive provides a way to query data in Hdfs, right? So this is one example. Okay, this is a very basic SQL construct, and Hive allows users to query data using HiveQL. Okay, we have seen all this. Okay, so also that note that Hive is not an RDBMS. So Hive Metastore, so we can see that it uses Apache Derby, and however it can use MySQL, as a Metastore. And so these are some other, commands. Hive deployment. So one of you were asking about Hive deployment. See, this is a CLI. Okay, and we have a Metastore in between. So it creates and accesses the Hive database schema. So this is the Metastore, and then it fetches the data from the Hadoop cluster. So this is as simple, okay, as the deployment of Hive is. And then I wouldn't mind showing you the Hive server 2, okay, which I just mentioned. So Hive server 2, wherein there is a shared Metastore, okay, and so you have the beeline CLI. So there is a difference between Hive and Hive server 2. Okay, this is a Hive server 2 deployment, and most of the stuff remains same, whereas the differences between the Metastore and the CLI, this is beeline CLI, and this is a shared Metastore, and you also have the Zookeeper out there. Okay, so Hive Server 2 wasn't very popular. However, yes, I won't mind showing you Impala. Okay, so Impala also allows users to query data in Hdfs using HiveQL. It's open source and created by Cloudera, and uses the same Metastore as Hive uses. Okay, but see the difference. Hive, unlike Hive, Impala does not turn queries into MapReduce jobs. Why? Because Impala runs on additional set of daemons, okay, that are often referred to as Impala servers. Okay, so Impala daemons are all a part of the data node. So you can see here, Impala server is resident on every of the data node out there, right? And that is the reason that Impala often provides you a 10 to 50 times faster, performance. Okay, so that's one thing to see. Okay, uh, I think I'll turn back to our regular slideshow, and if you would like to see the Impala thing happening, then we can run the same thing on Impala shell over here. Okay, I'll go into Impala hyphen shell. Okay, and then we can actually run the same thing uh, or more so. Let me just come out of this, and I'll show you the Hive join, right? So what we do is select this entire thing, okay, and we'll go into the Impala shell, right? And you know how much time the Hive took, okay, to run this. And I'm going to do this. Okay. So somehow Impala is not able to read the uh, you know, read the Metastore. So what I'll do is, in such a case, what you can do, go to your uh, view interface, right? So I'm in view interface there. What I would do is just to restart the Impala. So I've just restarted this, and let's see if Impala shell now gets. It's quite strange. Am I sharing the screen or? Yeah, screen being shared. So go back to this and start with the Impala. Well, it seems that Impala needs to be restarted. Okay, it's not able to read the meta store. So that's the only problem, that for some reason it's not able to read the meta store. Let's just do invalidate metadata. Okay, yeah, this is what needed to be done. Okay, invalidate metadata. So now it's refreshed the metadata and able to read. So the point was, I was telling you that I will run the very same query which we ran on Hive. Okay, this is the query that was there. So I'll once again select that query and run it for you, so that it joins. It does a join, okay, between the two tables. So there goes a join, and what we are going to do is very simple. Okay, these are the two lines, right? I'm just going to paste it on the Impala prompt. So see, it's not going to run MapReduce, but it makes use of more parallelism. So after this runs, okay, now see, this is even better output that we have got within Impala, right? Than it ran on Hive. So see, it is coming in each of these such columns. Okay, we see the IP, we see the country. It's very well structured. Okay. Now coming back to our Hive query language. So we'll finish off this slideshow, and then we can take a break. Then we can go back to our Cloudera machine to run a full big data project demo. So the Hive query language, let me know when you guys need a break, okay? We can stop when you need a break. So this is one of the MapReduce queries, and the Hive query language, right? So this is broadly pictorial representation of the HQL, okay, the way Hive query language runs. Right. So I hope HQL is, you are familiar with HQL, right? There is a book, okay. Let me just get to see the name of the book. I'll just mention which book it is. Hold on. So, okay, I've got the book's name just now. Can you tell me the scenario where we go for Impala instead of Hive? So, Chandan, that's a good question. See, we go for uh, most of Impala deployment when you are doing Cloudera. Okay, let's say you are a big customer who has procured INR worth of, let's say 1 crore INR worth of hardware and software from Cloudera. Okay, to put it more subtly, there is something called as Oracle Big Data Appliance. Okay, Oracle Big Data Appliance is a full hardware rack. Okay, it is a starter rack. It comes with 4 servers. Okay, and you can scale it up to many servers, 2 racks, 3 racks, spanning 50 servers and 100 node cluster, and it will be called as a Oracle Big Data Appliance. So I'm just writing it down for you. Can you explain where it's, so there is something called as Oracle Big Data Appliance that uses Cloudera CDH across the cluster. Okay, now see, there was a time when Impala was not created and Oracle sold only Hive to their customers, right? Now the customers came out with an issue that Hive queries are taking a long time. So Cloudera was forced to make implementation like Impala. Okay, so Now the entire 50 nodes will have Impala daemon, and it will be much faster. So it will be 50 times faster than this one. So that is the need of Impala coming up. So most of the users who were using Hive, they sooner or later switch to using Impala. Okay, if you are on a Cloudera setup, if you are on a Hortonworks setup, then yes, you have to use something else altogether. So Spark is something that is very common these days. Spark is becoming popular. So people are following and adopting Spark as a parallel technique. So I guess you would have got my explanation to this. So guys, we'll take a break of about 10 to 15 minutes and get back to complete our today's session. And I would appreciate if you have any queries. And let's get back after this break. Yeah, thank you. Okay, I'm back here. So the next thing is in continuance with our Hive itself. Okay, so at this point, see, for those who are coming from database, Unix or Linux background, okay, they would have got the concept of Hive, okay, and when we have to run Hive, okay, it can be run as you have seen in web as well as in CLI. So I believe you should be comfortable on Hive. The handouts that I have provided, okay, which includes working with Hive and the two other PDFs happen to be the data sets. You can at least start working on this particular technology. So we can conclude for the Hive, okay, which is a good explanation, provides pros. Okay, the pros are good explanation of Hive and Hive HQL, and architecture is well explained, and the usage of Hive, and cons except only a subset of SQL queries and performance comparisons with other systems would have been more appreciable. Okay, so these are the some of the features, okay, that we have seen in Hive, and we can continue into looking at the Hadoop, which has been adopted by these any number of companies, including Facebook, Yahoo, Amazon, and so forth. So I will take you to the our Cloudera virtual machine, right, wherein we'll be doing a lot of other stuff which we could not get time earlier. Okay, so you do have a many number of things. So I'm sharing that application now, our virtual machine, and this is not just restricted. If you see the hue over here, okay, HBase, Impala, Spark, these are all the things, okay, that are provided in this, and we may not have enough time to run through each and every of these. If you have any questions regarding any of these, do feel free to ask about Spark or about any of the technologies. So I can, if I can, yes, I will answer to your queries. So I'll continue to these small Hadoop projects, wherein we were yesterday probably on the step where we had uh, ingested and imported one full table from MySQL, okay, into Hdfs, right? So that was the first thing. Then we move on into bulk upload of data. So if you would like to bulk upload, see, these are the commands that you can use. So first one is sudo hdfs mkdir. So that is the basic mkdir, and then I'll run these two commands over here. That is the first, mkdir access logs, and then we do see here that there is, in this directory, there is some access logs. So before actually putting this, I'll show what is there in this particular location. Okay, this is what the file we are referring to. I'll show in human readable. It's a 38 megabyte file, which we are now with this command, okay, uploading in Hdfs. So this is a very regular command I have used so many times, and you can also see it's going into the warehouse directory. So by straight away putting into warehouse doesn't mean that we are also schematizing it. Okay, we have to schematize it later on. And see, this is what the command it says. Okay, it tells us you can now build a table in Hive, okay, and via Impala and Hive, okay. And see, first you will take advantage of Hive's flexible Surday, okay, to parse the logs into individual fields, okay. And second, you will transfer the data from this intermediate table to one that does not require any special Surday. So it says we can use this. Yeah, we can either use this in the terminal, okay, or you can also use it in a separate Hive prompt. So I'll just start Hive over here. And we'll once again look at the syntax, which is create external table, access logs, and this is where it has to read it from. Right? If you recall, if you just see, this is the user Hive warehouse original access logs, right? Original access logs. This is where it is. And what we could do is, we have started Hive, okay, and I'm going to run this over here. Let's see the output. So the time taken so much. So this is complete, and we also do the second one, which is create external table, tokenized, and give the location, add the jar, and also insert, overwrite. So that's the next thing. Insert, overwrite table, token access logs. So see, this is the reason we should be familiar with the Cloudera virtual machine, and I've been telling you to download. Let me know if anyone has downloaded the Cloudera virtual machine, so that you can be up and running with this. So anyone now who has downloaded this? Any one of you who can answer me to? Okay, yeah, Satya has. Great, very nice to know that you have it. So see, until you have the Cloudera VM, you won't really get to do the hands-on, right? And do not think that you need to have hands-on Linux or Unix operating systems. Even without the hands-on, you can at least work on it. But more so, it is good that you can learn Linux and get started with it, right? So it's good to get started and to start learning Hadoop in Cloudera system. So we'll run invalidate metadata within Hive, and then it says if you enter the show tables or refresh the table list in the left-hand column, you see the new external tables. Okay, so two new external tables were created. So I'll once just do show tables. So what were the new? Insert tokenized access logs. So this is one thing, tokenized access logs, and the other one is your create external intermediate access logs. So you have intermediate access logs. So if you would like to see what these two have done, see, we are created a table. Who can tell me what kind of a structure it has created or where it has created? Anyone who can tell me where this structure has got created? Let's see who answers first. Where has it got created? In the metastore, isn't it? It's got created in the metastore. And it happens to create IP and such structure, okay, from Surday, right? This is the serializer, deserializer with Surday properties. This is now giving a input regular expression. So we had these access logs, and access logs had these kind of expressions. That is why we have given. then create external table tokenized access logs, and these are the ones that appear. So finally, we get to add a jar file and insert override. So these are the two new tables that we get with this kind of a structure. Yep. And if we go next, what we are doing next is select count URL from our tokenized access logs where URL is product. So broadly, we are running this Hive query. Why is not run? Okay, actually it's not run because of a certain reason that we have provided it into a single, different lines without a backslash. So when I do it in a single line, that's when it will run. So I'll paste it here, and it should. Yeah, this is what is. So let's do a select star from. Let's see what happens there. If we do a select star from access logs. Okay. Select star. Yeah, that is okay. This particular step was missing, so we did not run this step, okay, last time, and now it should run. So let us see once again what this is doing. Okay, I'll take you to the top of the screen, and the exercise says correlate structured data with unstructured data. Since you are a pretty smart data person, you realize another interesting business question would be, are most viewed products also the most sold? So see, this is a very critical question. That is, if you go to Flipkart or Amazon and see a smartphone there, and you access it, let's say 10 times a day, but you do not happen to buy it, and it is not just you but almost all the users, okay, which happen to go and see the product but do not happen to buy that same product. Now, isn't it so very, very astonishing that as a seller, I get to know that everyone is looking at this product but nobody is buying it. People may be giving a 5-star to it but nobody is buying it. So there is certainly some problem somewhere. So that is why that is what the reason is that we started this exercise, right? Since Hadoop can store structured and semi-structured data alongside structured data without remodeling an entire database. See, this is a very important line. Can store unstructured and semi-structured data alongside structured data without remodeling an entire database. You can just as well ingest it, okay, along with weblog events. So we have the weblog entries, okay, which we had in fact ingested. I had uploaded. See this one. These are the weblog entries, right? Original access logs that were uploaded there, right? And so in exercise 4, later in this tutorial, you can explore Flume configuration example. So there is another Flume that is coming later, but let's first finish off with this one. So we were not able to do this step because last step was not done probably, and now that it has been done, so let's see. Let's just try to give this now and see if it runs. So we have the same problem, again. So what I'm doing is in Hive, I'm going to do drop, okay, external table, and you can give like this. Okay, I'm dropping the table. And I'm also going to drop the tokenized logs, because it seems that these tables have not been, created properly. So I'm going to create it one more time, and by giving this syntax, we'll create it. And by giving this syntax, we'll create this. We'll give the add jar file separately. This is being added, and now we do a insert table, insert override. Okay, so we have two tables, and select star from intermediate. So this is the intermediate, this is the tokenized. And let's get this created first. Any questions up till now? Okay, now, so that is done. Now let's move on into invalidate metadata. Before doing this, I'll come out of the Hive prompt on my Windows system. So I've come out from there. I'll go into this and hit invalidate metadata. So this is giving a trouble, you see. Let's go into the Hive. Hive is not open anywhere. So why is this giving trouble? So we are through till this point. Oh, we got to go to Impala here, my dear. It has to be done in Impala prompts. So it says, see, you need to do this in Impala. Switch back to Impala query editor app and enter invalidate metadata over there. It's not supposed to be here. Impala shell, that's where give invalidate metadata. And then it says, now if you are using the show tables, okay, paste the query into your query editor. So I guess it's saying put it into the Impala query editor. Let's go and see. See, it's in the Impala query editor. So we'll actually go and put this entire thing, okay, in the Impala query editor now. So back into this, I'll just locate my Impala query editor. So I'll have to share my screen now. Share the screen, and this is where you should be able to see the Impala query editor. And I'll once again get the text that we wanted. So this is the text for Impala, and see, that's the query that we need to be putting. We need to put in Impala, and I'll hit enter. And see there, see these are the rows that are outputs, and we are going to interpret this output very soon. See, it says you should see the similar output as the one below. And see the explanation. If one of these steps fail, okay, then you have to do this. By introspecting the results, you quickly realize that this list contains many products, okay, on the sold item, but there is one product that did not show up in the previous result. So there is one product that seems to be viewed a lot but never purchased. Why? See the first one, which is missing. So in this example, in the data company, okay, someone figures out that on that view page where most visitors stopped, the sales path of the product had a typo in the price for the item. Once the typo was fixed and the correct price was displayed, the sales for that SKU started to rapidly increase. So see, the people were not actually able to go into it, and that is how people were looking at it but not able to buy it, right? So this is the reason that the analyst, has found out has taken place. So next scenario is your management is thrilled with recent discoveries, okay, and you are excited to dive into more of these. So we have a Spark, example over here, and uh, the use case says that you come up with a great idea that it would be interesting for marketing team, which products are most commonly purchased together. Okay, but perhaps there are optimizations to be made in marketing campaigns to position components together that will generate a strong lead pipeline. Perhaps they can use product correlation. Okay, so we are looking at this keyword as product correlation to help up the sales for lesser viewed products or revenue forecast. Okay, so we can use the Spark shell for this, right? It is also available over here. You can go to Spark, okay, from view, and you can go to Spark shell. So I'll show you for a brief moment. I'll come out of the Hive and I'll run the Spark shell. Okay. We are going to the Spark shell, and so these are some of the things that we need to import. So see, Spark is altogether a new thing. If you are okay with Java and Scala language, then you can learn Spark to a great level. Okay, so Spark is a platform basically, again, which runs over Hadoop. Okay, so we have Hadoop running and we have Spark. Now let me tell you one thing. Spark and MapReduce are two parallel things. Okay, either you will be running Spark on Yarn or you will be running MapReduce on Yarn. Either of the two can run. So these are the few import statements. It's basically a program, okay? It's basically a full program that we can be running. So once the Spark thing comes up, I think we can not just, I guess you can just click on copy. Okay, so text copied, you can place it over here. Entire text has been copied, right? And then see, this is the Spark prompt. We can put this into the putty session also. How are you finding it? Any questions up till now? Any further questions? I hope you are following this. Yeah? Let me hear from you. Nobody is very active today, it seems. Okay, good. Thanks, Chandan. So I'll go back into our Cloudera, okay, and we have the Spark being started over there. So you mostly program Spark in Scala language. Scala has been developed in Java, okay, and there are an ample number of books on Scala as well. So if you go on to become a Hadoop developer, then yes, you can make use of Scala to program in Spark. So see, Spark is actually very straightforward. It uses resilient data sets, so which is also called as RDD, okay, in short. And we would just, so if you have used in-memory analytic tools, then you will understand it. So we, in Spark, we will just give an assignment saying that X is equal to a complete file. So it will read that full file, okay, and that's how it is called as a resilient database in memory computing. So although it doesn't read the entire file, it is just declaring that file. So somehow Spark, I think, is taking more time. I think because we have given these options over here, yarn client. I guess Spark would have very quickly started if we did that over here. So I'll do Spark -shell. It's taking more than usual, probably because we've been running this for quite long, and I just happened to put the system on sleep while my virtual machine is running. Even VM is, so I never reboot really. That probably would be the reason. Okay, so see, this is the Scala prompt that we get, and what I'm going to do is just copy the entire program, okay? But then before copying, I want you guys to know what our program is doing, right? So see, the first few are import statements, just like a regular any language, okay? Like in C++, we say include, right? Standard input output dot h. In C++ also, we say that use this particular header library and all that. So same thing, import. Then we go for defining, right? So this is the RDD, right? Whenever you see RDD, it means it's a resilient data set, and we are assigning it as a format, file format. Then we say value warehouse equals to this particular. So this is a variable declaration, 3 of them, 4 of them. And then we start with value orders equals to a join statement, right? So join products.map and so forth. So we are doing all this in the Scala language. And the same thing you can put as a file also, just like in Hive we saved it as a HSQL. In Spark also this can be saved as a .scala output, and then we can run it with within Spark. So when we run Spark, okay, we get the Scala prompt, and all I'm doing is just pasting the code that has been copied from there. You see, it's getting started to run over here line by line. So it's taking more time because we can compare it to MapReduce, okay, because although Spark does not do MapReduce computation, but still the computation is very, very compute intensive, right? So see, this is the output, right, that we are getting as per the intended requirement. So it says that to better understand the script, you could read through the comments in each of these. Okay, when we do a map, so it's like a map reduce. Okay, we specify a function. Okay, and then that will take each record and output a modified record. This is useful when we only need a couple of fields from each record. Okay, or when we need the record to use a different field as a key. So it is explaining how your this program is running, okay, or is going to run. The reduce operation. So if you see the program, okay, in these comments, see there. First, we are going to import the classes. Then we create the RDDs for two files that we imported from MySQL to with scoop. Okay, remember the two. Okay, what we had imported. So RDDs are Spark's data structures. Okay, for working with distributed data sets. Now let's see where it is reading it. Now see, this is the value warehouse. Remember, quick start user Hive warehouse. This is where our warehouse remains, and within that it is reading the order items and products. So if you would like to see it again, I'll open a new prompt, okay, and go to the MySQL. It's become somewhat slow. Let me check. So there is nothing like MySQL here. There also. So I think it will be in these two prompts. Yeah, I can actually go here, MySQL. It's quite strange. I think this was root thing. I have somewhat forgotten what was the username for this. But anyhow, I can check that in this guy, and we can see where the thing was in tutorial exercise 1. So user is -u. Okay, so retail DBA was the username and the Cloudera. See, this is what the username was. Okay, this is the original scenario. Okay, and I would show the databases first, and we'll use the retail DB, right? So use retail DB, and then show tables there. See, we are talking of products, okay, and I think the order items. Products and order items is what the Spark is using, right? Next, we extract the fields from order items, okay, and products that we create about, and get a list of every product, its name and quantity grouped by order, okay. So val orders and then order item and join. So it's joining two tables, right? Okay, orders and products, and then you get, finally we tally how many times each combination of products appear together in an order. Then we sort them and take the 10 most common ones. So as what it is saying, that you will get an answer or a output like this. This is what we've actually got over here in the output. Where's the output? This is the, where was the output? In scalar, right? This is where it was. See there, that is the output. So it shows that Nike men's dry fit, Victor, victory, golf, polo, and perfect. So we have on the left hand side one other parameter. So see, these two outputs are very similar as expected. Yeah. Now what is the conclusion? If it weren't for Spark doing co-occurrence analysis, this would be an extremely difficult exercise for us. So that's one more, okay, and then we have unified storage for all of your data. So let's see what is there in this particular exercise. Explore log events interactively. So see, log events are basically when you do what you can do to enable guided drill down and exploration of data is to make it searchable by indexing your data using any of the index options by Cloudera search. So see, this is another very complex exercise. Okay, you can choose to batch index using MapReduce indexing tool or use our example with Apache Flume. So I told you Flume, okay, earlier, that does real-time ingestion. Okay, configuration that is already ingesting the weblog data to also post events to Apache Solr. So Solr is the Cloudera search tool. Okay, so in this case, it is a further very difficult exercise to perform. Sometimes you may come across errors also. Okay, and it provides you with a complete step-by-step analysis. So probably yes, I can start off with this, but I don't know if we'll have enough time to perform and finish this. Right? What do you guys say? I think we can halt over here, and I would rather look forward to hear from you. I have mentioned my, email address, and you know about my LinkedIn profile. So I guess you can check my LinkedIn profile and see any updates, okay, on the LinkedIn as well as SlideShare. Okay, I do have a lot of developments going on these days, along with some government agencies and private corporates. So any of the advancements that I am doing, you can always follow me on SlideShare and LinkedIn as well as Twitter. So Twitter handle is also available on my LinkedIn profile. So I hope you all have enjoyed these sessions on big data and Hadoop. And personally, I would wish you all the best in your careers, going forward. So I'll just look forward if Viral is here, so that we can conclude our today's session. We have a few more minutes, so let me know if you have any questions, regarding big data, Hadoop, and these technologies that we have covered in these days. Storm, okay, yes, go ahead. Storm is actually the recent tools. So, see, personally, I am involved into the projects, but I can definitely tell you about Storm. If you guys have not gone through the what do you call, through Tutorials Point, okay? Tutorials Point is Hyderabad-based website. So they provide very fine tutorials. Okay, so they have PDFs. I strongly suggest you go ahead and do that. So Storm, I will just tell you about it. Hold on. So I have been into some courseware development as well. So see there on your screens, you should be able to see introducing Storm. Apache Storm is a distributed stream processing computation framework written in Clojure language. So shall I tell you something common over here? See, Clojure. Hold on, give me a moment, please. So guys, okay. So I got a question, okay, on Storm. So the Clojure is quite a popular language, and rather many people don't know about it. So I shouldn't be saying that it's a popular language. Many people don't know about it. So originally created by Nathan and this one, okay, and it's acquired by Twitter, okay. So it's broadly used by Twitter, right? And I do have one use case. I mean, just down the stream, we have a exercise on Storm. So Storm basically, is like if one is sending a message, it is like in real time. It's very similar to Flume, how it is being, fetched by another person from other end. So see, and it uses custom created spouts and bolts to define information sources and manipulations over batch to allow batch distributed processing of streaming data. So streaming data is a keyword, okay? Initially released in 11. A Storm application is based on a topology in a shape of a DAG. So see, DAG is directed acyclic graph, which I told you is also there in Hive, with spouts and bolts acting as the graph vertices. Edges on the graph are named streams and direct data from one node to another. Together, the topology acts as a data transformation pipeline. As a superficial level, the general topology structure is similar to MapReduce job, with the main difference that the data is processed in real time as opposed to individual batches. Additionally, Storm topologies run indefinitely until kill. Okay, so Twitter extensively uses Storm, right? And became a Apache top level project in September 14. So for a while, I'll pause the screen. I'll take you to the. There is a exercise on Apache Storm, which I can show that. See there. Do you see the Apache Storm exercise? So you can install it. You just need to do an unzip and get it installed. There are some this RPMs. Okay, so just install cd storm installer, and so that is running. And so once it is running, then we can install it and even have an application running over Storm. So you see this one that you just saw was a Storm introduction. Okay, it's very much similar to Flume. So if we had more time, we would have gone back to the Cloudera CDH and also seen a use case. But then that's what is restricting us. And to go further, I have some concluding slides about the history of databases, which was previously in 1990. Then we had relational dominance. Okay, from 2000 onwards, many applications are very popular, like Oracle SQL Server. Okay, have gained so much of dominance in around 2000 onwards till 2010, and even these days. So of late we also have what is called as a NoSQL database. So I wouldn't mind showing you my screen once again, and a couple of websites out there. So I would just display the website. See, this is the website where you'll find a complete e-library, and if you go to computers and IT, so this is paused. Okay, this particular library, this is the URL, all right. On this URL, you will be able to see a number of books, and it takes you to a further, sub library, and which is this computer section. Within that, if you click on, let's say, Hadoop and big data, you will be able to see big data books and all. So there's no dearth of books available, and then all these are also being made available for reading, and that will be at a short duration. All right, so that duration is going to be mentioned over here. So it's there on the cloud portal. Okay, so just make note of this URL, and you should be able to read through the books and all the content that you require for development. So these the NoSQL I was telling you earlier, I mentioned that there are more than 10 NoSQL databases that you can master. Some of them are listed over here. However, you can get a bigger idea on Wikipedia. That is the amount of NoSQL databases available. Okay, now they are categorized. Okay, key value stores, then graph databases, then document databases, and column and family. These are the different categories in which the NoSQL databases have been categorized. So to provide you a brief overview, see, Cassandra and HBase happen to be very popular column N family database. Now column N family means that a regular RDBMS is created with a number of rows, right? We have specific columns, but the rows are so many, whereas HBase and Cassandra happen to be with a number of different columns. So let me show that on the Cloudera. So we'll go into Cloudera and move into mainly Hue. So we'll go to, from Hue, we can go into. So see, now that we are again going into Hue, what is reminded to me is these two putty windows. What I'll do is copy the output, and let me know if you guys are interested in the output and certain other documents. Okay. Certain other documents related to this, right? Related to these 2 days of webinar. So I will be happy to help you out, okay, in providing you the content. So that was our terminal 1. I'm coming out of this, and I'm coming out of this, and let's save the second terminal also, and I'll copy all, and that was 1. So we'll save the second terminal output there. Okay, I'll save it in a while, and I can come out of this window, and let's go back to, okay, I just saved the putty window session all this while. So I'll log in as Cloudera and Cloudera. Okay, I hope you are able to see this. And just as when you log into Hive, we can, set the Hdbase browser. Okay, so I just click there, Hdbase. So we are going a little over time today because the session was also started late. Let me know if you are pressed on time so that we can, wrap up the session a little earlier. And Hdbase browser has got installed, and we'll go and log in there. So that is okay. And see there in data browser, we have Hdbase. Any questions? The slide share link, yes, certainly. Hold on, I'm just providing you the slide share. Rather than slide share, you should also, refer to my LinkedIn, because this site that I'm running, okay, anyhow, Twitter, LinkedIn, all these, it is all there on the handout that you have. The 4 days of handouts, you have my details on the top. So okay, I'm just sending my slide share handle to all of you. Okay, can you please once again provide the slide share I just provided, and how to read file from directory without ad processing. Oh, that's a tough one. Chandan has asked how to read a file from directory using act processing using Storm. So, see, I would suggest you to go through the documentation. Okay, these tools and these technologies are very vast. We really have to go deep into the documentation while developing. So, I'm just, check the how is the market for Hadoop plus Spark now? See, Aadhaar card is there. The entire Aadhaar card for India, is getting public support. Okay, it has got a very strong government backing, and therefore there are. It is only 1%. Okay, from my side, it is just 1% of development happened for the Aadhaar card project. Aadhaar card is established by the government and the private corporates. But now there is this other 99% of applications, that is the scope still left in the Hadoop area, and Hadoop plus Spark, and whatever you say, it's Hadoop based. So Hadoop is here to stay for the next 10 years very easily. Some people do have this question that why did Aadhaar start with a Hadoop? Why did Aadhaar start with a Hadoop based, backend and a base as a file system? So the people who were inventing that time in the US. So I have got these this information right from the agency itself, from the people who have developed. During the time, Hadoop was the only open source or alternative available. So that is how Nandan Nilekani and other team members went into the development over Hadoop. Right? So the scope is huge. Scope is immense. So I'm just writing to all. Scope is huge and immense. So if you have interest, if you have options to develop, yes, please go ahead and continue your development. Right? So the screen that we have is almost the concluding one. I think so. Beside this, yeah, we were into the edge-based cluster. So see, I suggest that you should have Cloudera machine or a Hortonworks, okay, MapR or IBM Big Insight if you are going for Hadoop development. Okay, I do have all of these. So let me know if you have any queries or concerns. You can send me an email. Okay, and I would welcome it and would also respond. So today morning itself, I had responded to Gopinath, I guess, and there is no dearth of books, there is no dearth of content, and you are all welcome to get further trained from me and from Idura. So any other questions? So link is provided. Link I have just provided again. I'll reshare that once again. So, and hold on. What I'll do is I'll mention all of my handles, and you can have a, give me a moment. I'll share all of the links. Okay, there it goes. Any other questions? So I think we can conclude our today's session, right? Hope you've enjoyed and enjoyed these 4 days. I believe they were interesting to you and they were somewhat brainstorming because I've been continuously speaking, right? So you would have seen from my voice also, you would have heard it and known that I've been continuously, speaking out. So I would be thanking you to be attentive. There are 25 members as of now. Thanks to all of you present here, and I wish you the best in your careers and do the right thing in your careers and do it well. Okay, so that's the best wishes from my side. And well, I think we can conclude for today, and hope to meet you some other time. Yeah. Good, goodbye. So Chandan, sorry, Rajesh Rajesh response question I have just gone through. What is the market? How is the market for Hadoop plus Spark now? What are the technologies required for data scientist role? Difference between data scientist and data analyst. Data scientist has to do about everything from design, whereas analyst has to do Hive queries, pick queries. Okay, so there is a Cloudera data analyst course which covers most of Hive and pig stuff. But now the tools have also got expanded. So Rajesh, if you are there, uh, to become a data scientist, see through the courses, you need to have a strong mathematics background and a statistics background, okay? Because it is very complex when it comes to data scientist. Go through the Cloudera website and data scientist, and you will find what all is required. But I suggest not to jump over there, okay? Because whenever such roles like data scientists and data analysts are coming in the market, people often follow that bandwagon and end up spending lakhs, 2 lakhs, 3 lakhs, 4 lakhs into just doing these courses, and they end up not getting as much as they probably would deserve. So it's good to hear that you are interested in data scientist role, but just read through what all things are needed. So Python and R languages are a must that you have to learn for a data scientist, along with mathematics and statistics skills. Yeah, which anyone can learn, of course. So you can wind up and leave the session. Once you drop off, once you exit the webinar, okay, you will get a link for the feedback. So ensure to fill up the feedback, all right, before leaving your workstation. And then in the next 4 minutes, okay, that is by 6:20, I will end the webinar, right? Thank you all, and looking forward to see you at some other time. Hello everyone. So we are ending this session for today. Thank you for being present and wishing you all the very best. Thank you.